are going to learn how to remember thermodynamical potentials or energy functions. There are four thermodynamical potentials are there: internal energy, Helmholtz energy, and total heat function, enthalpy, and Gibbs function. Here we can remember internal energy from two basic equation connecting two laws of thermodynamics. du is equals to tds minus pdv. But it is difficult to remember these three remaining thermodynamical potentials. So that we draw a small box. Among those boxes, we place 1, 2, 3, 4. First thermodynamical potential, internal energy, Helmholtz function, total heat function, and Gibbs function. Above the box, we write T, S. Minus T and S, because here no minus, so we write minus here. And another arrow we draw here. Here we write PV plus PV, because here minus, so we take opposite sign plus PV. From this, we can write other thermodynamical potentials. For F, we write U minus Ts. Long arrow, U minus Ts. And for H we write U plus PV. And for G, we take both U plus PV minus Ts. G can be written as, by using this, H minus Ts. Simply by using this box, we can write all thermodynamical potentials. We can use them for change in second thermodynamical potential, Helmholtz function dF is equals to, we differentiate this equation, it becomes du minus d into Ts. So same, du means here we have du Tds minus Pdv. This is in u into v form. We do u into v form, Tds minus s dt. When we cancel Tds, we get minus Pdv minus s dt. This is the change in Helmholtz function minus pressure into change in volume minus entropy into change in temperature. Like that, we can further, considering F is a perfect differential, we can derive Maxwell's second thermodynamical relation, and third from total heat function, and fourth from Gibbs function. We can also define these functions definitions with this. For Helmholtz function is equals to the internal energy minus absolute temperature into entropy, or we can say internal energy minus energy taken from the surroundings by heating. And for total heat function, the total heat of the system is equals to the internal energy plus pressure into volume, or we can say internal energy plus external work done. And for Gibbs function, we can define Gibbs function is equals to the enthalpy minus absolute temperature into entropy. By this box, we can write all thermodynamical functions, and we can derive change in thermodynamical functions. By saying these functions are perfect differentials, we can derive Maxwell's thermodynamical relations.